so that's operating. Let me minimize briefly just to make sure that I didn't have somebody show up in one of the other classes. I do not. All right, so let me go back to you here. All right, if you would present your screen, and you can start your presentation at any time.
Okay. Is that showing?
It is, except for it's not the show. It's more like speaker notes is what I'm seeing. So
Okay.
I don't know. Whatever works, as long as I can see your slides clearly enough, you'll be turning them in anyway, and you just give me the voiceover. That's fine. So you can. This should work. Go ahead and try it. I'm seeing a slide that says engineering second quarter.
Okay. So in this, I'm sorry, could you please like mute your thing because I can hear myself a few seconds delayed. So it's
Hang on. Yeah. I need to mute my mic. Is what I need to mute. So give me a moment. Shouldn't be a problem.
okay. So there are so I will be going over the projects I did in my engineering second quarter. There are three main projects. Um, the first one consisted of trying to find the correct dimensions for a three-sided coin. The second was was creating a protractor arm which would fit a broken protractor that I've had for a very long time. And the last one was a box to hold one of the dimensions of uh, uh, of three-sided die that I'd previously made. So in the first one, I started with the question, how thick is a three-sided coin? A pencil will always either fall on its side. It will always fall on its side when thrown. A coin will always fall on its circular sides. So by the intermediate value theorem, there must be some point in the middle in which it, in which there is an equal chance of an object landing on its side and its circular flat face. Of course, that will be different depending on material and what material you're throwing on. But as long as I keep that controlled, I should be able to find some intermediate value. So based on a video that I had watched for research, I came up with an upper and lower bound, and then found some values in between that. And I won't go into exactly how I found them. I can say that for the thickness equaling half the diameter, that was a ratioing of the side of the rectangular cross section. And I'm wanting the thickness on the top and the bottom of that rectangle to be equal to the diameter. However, the other ones required all of this math. So it ended up being very complicated and not something I can go into in the length of this. I then printed the dice. I made making sure that the top the top engraving had the exact same volume cut out of it as the one on the bottom. There's an example of the shape on the bottom in the bottom left die, I believe. I then tested each of them, and I used frequency analysis to find which one to find their values, and of course, once I'm able, I will use a proper chi-squared test to determine the significance. The second problem I had was a protractor that I've had since elementary school that has been broken. So I decided to reprint an arm. I started with a semicircle attached to a rectangular body, and from there, I I added two I added two pieces, two rectangles coming out of it, as highlighted there, as well as the fillet on the bottom side of the rectangle. I then added a chamfer to one part of it because the outer edge of the protractor had a slant to it, and I added a donut coming up from the center of the semicircle that I had previously made. I then added a axis and plane to the center of the donut that I had extended and rotated a cut around it. And from there, I then used the pattern tool to create a pattern, as you can see on the right hand side of of 5 rectangles around a pentagon, and it ended up creating the shape on the left side. I then applied a few chamfers and a few fillets, and it turned out like this. I then also added the indent on the end of it because it would be hard to see the numbers sometimes with the original design because it was blocking, the halfway mark for whatever value it was. So I added it in an improvement so that I could more easily take measurements and whatnot. My next project was then a box for it. There's not as much to say about the box as the other two, mainly because its design was to serve more of a purpose of holding the dice I had made earlier. I decided to go with a box for the dice rather than the protractor arm because I felt that the dice were more of a full product than the protractor arm, which was more just a test of my prowess of Fusion 360, and it served more as a component than a full product. So the box is meant to hold 10 dice across, and it folds into a cylinder. One of the more challenging parts to remember was that distance was equal to the tiny difference in tiny difference in where the circle should actually be and where the chord of the circle cut off by the edge is. Yeah. Of course, the cylinder ended up being much more complicated than a rectangular box, which I was not initially expecting, but was certainly a welcome challenge. I ended up using all of these variables in order to define how many radians it had to go around the circle, and how long that meant it had to be, etc. And then, of course, I put it into the drawing. I created a drawing based off of the sketch that I had earlier. Okay. And that is the presentation.
Okay, nicely done. I'm going to see if I can stop the recording. Can you hear me again? Can you hear me now?
Yes.